All right, so complex fractions and order operations with fractions. So the thing that I don't like about our textbook for this section is the only order operation problems that they give us are ones that are complex fractions. So in order to see some different examples that aren't all complex fractions, we'll have to look at some of the lab problems. But we can do that on the lab. So the first thing in this section really, and I think we had actually talked about this when we did addition subtraction. Three ways to write a negative fraction, right? So you can think of a negative fraction as having a negative sign out front, a negative sign in the numerator, or a negative sign in the denominator, as long as there's only one negative sign, right? So those are the three different ways that you could write a negative fraction. Now, if there's two negatives in a fraction, recall that that fraction bar means division, right? So it's really kind of like you're doing a negative divided by another negative, and that would actually become a positive. So you never want to write a fraction with a negative in both the numerator and the denominator, because you would just write it as a positive. So it's not considered simplified if you write something like negative 3 over negative 5, right? Negative 3 over negative 5 is not simplified because it would just become 3 over 5. All right, so with that in mind, and this is just a quick little example. So which of the following fractions are equivalent to negative 3 over 5? Well, negative 3 over 5 is written in this second form like this, right, where the negative is in the numerator, but we can also write it in the form where the negative is out front, and that would be this one. Or we could write it in this form where the negative sign is in the denominator, and that would be this one. So those are the two fractions that are equivalent to negative 3 over 5, right? And remember what I had just said like a minute ago, negative 3 over negative 5, that's a negative divided by a negative, so that would actually become a positive. So these two fractions here are actually also equivalent, right? Negative 3 over negative 5 is actually the same as positive 3/5. So complex fractions, we had done simple ones of these when we had done the division of fractions, because remember, the idea is complex fraction, that fraction bar in the middle really just means divide. So this is saying A over B divided by C over D. And then once you do your keep change flip, it becomes A over B times D over C. So it's just turning it into a division problem and then doing keep change flip. So it's pretty simple, right? So like 2/3 over 5/6, you'd write that as 2/3 divided by 5/6. And then you would just do your keep change flip process. Keep, change this to multiplication, and then flip the 5/6 to 6/5. And then now you can do your brute force method of multiplication, which I think we had said was probably the easiest for our purposes in this class. So you're going to do 2 times 6, which is 12, over 3 times 5, which is 15. And then you got to reduce that now, right? Simplify it, because what number will go into both 12 and 15? 3, right? So 3 will go into 12 4 times, and 3 will go into 15 5 times. So that just becomes 4/5, right? Because again, what are you doing there? It's really like you're dividing the top and bottom by 3. And these other ones are all similar. The second and third one are actually good to make the distinction between, though, because in the second one here, it's negative 8/7 divided by 4. And that 4 is really 4 over 1. So then you would rewrite it as negative 8/7 times 1/4. And now doing brute force, negative 8 times 1, 7 times 4, 28. And now we reduce this, right? Negative 8 over 28, 4 will go into both of them. So negative 2 over 14. Because what you're really doing here is you're dividing by 4. And it's not 14, right? That's why it's good that I wrote this out, because then I can see it. Negative 28 divided by 4 is actually 7. Negative 28 divided by 2 is 14, right? 28 divided by 4 is 7. So it's negative 2/7. And now here's the distinction between that second one and this third one. This third one is not negative 3/9 divided by 10, but it's negative 3 divided by 9/10. Because what you have to do is you have to find like the big division bar, right? The big fraction bar. In the case of the second one, this is your big fraction bar. In the case of the third one, this is your big fraction bar. So that's negative 3 divided by 9/10, which then becomes negative 3 times 10/9. And then we'll do brute force, right? It's negative 3 over 1. So negative 3 times 10 is negative 30. 1 times 9 is 9. And then 30 and 9, 3 will go into both of those, right? So divide by 3. And then you would end up getting negative 10 thirds, right? So let me just highlight these ones that were the final simplified versions. Right? And then the last one, this one just involves variables, but it's the same idea, right? A over 8 divided by AB over 6. And then we do keep change flip. A over 8 times 6 over AB. And then brute force, A times 6 is 6A. 8 times AB is 8AB. And now what happens here? The A's will cancel. And 6 and 8, 2 will go into both of those, right? So divide by 2, and you end up with 3 over 2 goes into 8 4 times, but you still have the b left. So it's 3 over 4b, right? And when you write this, you got to make sure that you put the b in the denominator, right? The b is not in the numerator, it's left in the denominator. Now sometimes variables are left in the numerator, but in this case, no. The variable is left in the denominator, so it's just 3 over 4b.